formula. The quadratic formula is not something you have to memorize. You just need to look at your reference sheet with the formula on it and apply it. Where do the A, B, and C come from the formula? Well, it comes from the quadratic equations. So you've got your A in front of your x squared, your b in front of your x, and your c, which is your constant term, the number by itself. So let's just practice finding your a, b, and c. Your a is 3. Your b is negative 2. And your c is 49. That is your a, b, and c. Now, that's not all that you're going to be doing when you're solving these problems. It's just it's important to be able to find your A, B, and C. Otherwise, you're going to have a hard time doing the problem to begin with. So I'm going to write down the formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. What I'm going to do then is I'm going to write down my a and my b and my c. My a is 2. My b is 5, and my c is 3. What we're going to do is we're going to plug those values into the formula. So it's negative b. So I have a negative 5 plus or minus the square root of b squared, b5 squared. 5 times 5 is 25, minus 4 times a, which is 2, times c, which is 3. All over 2 times a, which is 2. Now it's just plain simplifying. So I've got negative 5 plus or minus the square root of 25 minus 8 times 3 is 24, all over 4. Negative 5 plus or minus the square root of 1 plus 4. What this does is it lets me break this down into 2 parts. I've got negative 5 plus the square root of 1 is 1 over 4. And I've got negative 5 minus 1, the square root of 1, is 1 all over 4. This gives me negative 4 over 4, which is negative 1. There's one of my answers. And this one gives me negative 6 over 4, which is negative 3/2. I would not have used the quadratic formula on this one. I probably would have factored it and solved it in that form and still came up with the same answers. The next one that we have here is quadratic formula. We have a is 5, b is 3, and c is negative 1. So what we're going to do is we're going to plug those values in. The formula again is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Alright, plugging in those numbers, I have negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a times c all over 2 times a. One of the things that people are going to make mistakes on is their negative and positives. So we're going to have negative 3 plus or minus the square root of. This is 9. I would suggest changing this to plus the opposite here. So you've got negative 4 times negative 1, which is 4 times 5, which is 20, all over 2 times 5, which is 10. And actually, let's jump back up here for a second and just change that. And I'll change this one as well. So I'll change this to be 10, and then I'll put this was 2 times 5. I just didn't plug in the 5. Alright, so what I end up getting is negative 3 plus or minus the square root of 29 over 10. This is the final answer because the square root of 29 cannot be broken down. So I've got 2 answers, negative 3 plus the square root of 29 over 10, and I've got negative 3 minus the square root of 29 over 10. These would be 2 decimal answers, but we don't need to figure out the decimal answer. Alright, for the next problem here, I'm going to go ahead and figure out my A, B, and C. So my A is 1, my B is -10, and my C is -40. These always should be plus signs, so that's why I know they're negative values. The formula says negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Plug in your values. -10 actually makes it be a positive 10. B squared is 100 minus 4 times A times C all over 2 times A. So I end up getting 10 plus or minus, this would be 100 plus the opposite here, -4 times -40 is 160 all over 2. 10 plus or minus, we get 260 all over 2. This can be broken down, so I'm going to need to go off to the side and do a separate problem for the square root of 260. The square root of 260 is 26 times 10. This is 13 times 2. This is 2 times 5. So I have a pair. It's a pair of 2's. So I have 10 plus or minus 2, the square root of, these stay on the inside. 13 times 5 is 65 all over 2. Now when you reduce this, the 2 has to be divided by the 10 and the other 2, only things on the outside. So my final answer is going to be 5 plus or minus the square root of 65 over 1, which we don't need to write. This is the importance of quadratic formula, because not all the time, just like in the last one and this one, do we come up with whole numbers or fractions. And so we have to have a method that will allow us to be able to figure out those answers. On this next problem, if we go ahead and use these 4 numbers, they're going to be such big, huge numbers that they'll be horrible to work with. I couldn't do this on any of these other ones because they didn't have any like factors. What I mean by that is they didn't have something you could divide everything by. On this one, I can divide everything by 4. And I will, because it will make it much easier to deal with the quadratic formula. So what I end up getting is 1x squared plus 2x minus 9 equals 0. Please, if you notice that something shares a like term, please divide each of those, because it will simplify and make your work much easier. So now A is 1, B is 2, and C is -9. Plugging in the formula, negative B plus or minus the square root of B squared minus 4 times A times C all over 2A, I end up getting a -2 plus or minus 2 squared minus 4 times A times C all over 2 times A. So I get -2 plus or minus 4. Change my sign to plus the opposite here to make sure I have the right term in here. Negative times a negative is a positive, so I get a positive 36 all over 2. This gives me the answer of -2 plus or minus the square root of 40 over 2. The square root of 40 can be broken down. The square root of 40 is 20 times 2. 20 times 2 is 5 times 4. And so 5 is prime, 2 times 2 is 4, and 2. So I have a pair of 2's, and the 5 and the 2 will stay on the inside. So I end up getting -2 plus or minus 2 the square root of 10 all over 2. 2's are all divisible, and so I end up getting -1 plus or minus, I don't need to put 1 square root of 10, I can just write square root of 10. Okay, I have one more problem for this section, and we'll just run through it really quick. So I've got A is -3, I've got B is 5, and I've got C is -1. Formula again is -B plus or minus the square root of B squared minus 4 times A times C all over 2A. Plugging in those values, I end up getting negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times a times c, all over 2 times a. And all I'm doing again is plugging in each of those numbers. So I get negative 5 plus or minus, this is 25. This is negative 12, and then, or positive 12 times negative 1 is a negative 12, so minus 12 all over negative 6. This gives me negative 5 plus or minus the square root of 13 all over negative 6.